All right, so we're moving on to the section 1.4, continuity. There's 2 days worth of this. So day 1, we're going to think when you talk about something being continuous. So if something is continuous, let's say x equals c, that means there's no interruption in the graph at that c value. So the graph is unbroken. There's no holes, there's no jumps, there's no gaps. So the figure below, the 3 diagrams, identifies 3 different ways at which a function is not continuous from the points from A to B. So in the first case, you have f of c is not defined. So there's a hole, okay? And we can even, right, we have a hole going on there. In the second situation, as you're coming from the left, again, we're still focusing on limits. So as you're coming from the left-hand side and you're coming from the right-hand side, you're approaching 2 different values because there's this gap going on. So there's sort of like a jump occurring from one point to the next if you follow the function. In terms of continuity, it means if you put your pencil down, you followed it along, we have to actually jump to get to the next piece of the function. And with the last one, that's another instance of, say, where a hole would be, because you have a closed point underneath it, but you have a hole at the particular location where your actual function is coming from the left and the right. So it says in the figure above, it appears that continuity at x equals c can be destroyed at any one of the following conditions. So something is not continuous if, number 1, the function is not defined at x equals c. Number 2, the limit of f of x does not exist at x equals c. So that's the second instance. And for c, or the third diagram, the limit of f of x exists at x equals c. So in the third case, the limit is the same because as you're coming from the left side and as you're coming from the right side, you're approaching the same value, but it is not equal to what you get when you plug c into the function, which is f of c. That's how we would note that. So if none of the 3 conditions above are true, so if nothing above holds true, none of those are occurring, that means the function is continuous at c. As indicated, you can scratch that next part, okay? The function is just continuous. We'll just stop it right there. So if a function is not continuous, then there's something called a point of discontinuity. And there's 2 types of discontinuity that can occur. We can either have a removable type of discontinuity, or we can have a non-removable type of discontinuity. So a removable type of discontinuity would be like a hole in the graph. So hole in graph. So here's your function, and whatever the function may be, you just have that gap. So that would be like A above in terms of if we were labeling these A, B, and C. Now, in terms of non-removable, you have 2 types of non-removable discontinuity. The first type is when you have a vertical asymptote. Okay, so vertical asymptote, and that is an instance where if you look at your graph, those are your rational functions, where the function is approaching, but it never is going to touch. Okay, so it's never going to actually, let's just say that point is 3, so it's never going to actually cross the line of x equals 3. That's a type of non-removable discontinuity. Type number 2 is something called a jump. And we had graphed these when we talked about limits in section 1.3. So this would be an example of a jump, or B above would be an example of a jump. But these are both types of non-removable discontinuity. And what you're going to be doing is you're going to have to identify when they ask about continuity. Is it removable or non-removable if it is not continuous? And what kind, hole, vertical asymptote, or jump would apply?